Alright, this is going to be a quick tutorial on how we can get the X-Alta2 onboard computer code flashed and the ground station code running so that we can test the code in development with the development board. So currently I have the Texas Instrument TMS570LC43 device connected to my desktop computer, and I also have the USB to TTY logic cable connected to the development board, and that will let us send data out the USB port and have it arrive as serial data on the development board. So for this example, I'll just show you the end result. Will be basically we'll have the onboard computer code in Code Composer Studio, and then we'll be able to debug. So upload this code to the device, which will take a short moment. I'm just going to remove my breakpoints. And the debugger always stops at main, so you just have to go ahead and hit start. One thing you can do to verify that the code is running is just pause it and make sure that it is somewhere you'd expect it to be, like in the operating system. And so once we're done this tutorial, we'll be able to be running this code. And then my setup is that I have a virtual machine running to run the ground station code. You could also run this entire setup in Ubuntu. Depends on what you have access to. But currently I'm in Windows using a virtual machine. So here's Ubuntu. Here I can run the ground station code with the UART interface. And then I can send commands to the onboard computer through the USB. Something like that, which just set the time, and then now we can go onboard computer. Sometimes it doesn't connect the first time. Or the second time. But you can see eventually it gave me back the time that I just set it to. So let's go ahead and see how to get this all set up. Just going to close this. So the first thing you're going to want to do is head to the EX2 onboard computer software repository. In here we have Git submodules for the libcsp network and the EX2 services. So we can go ahead and clone this. It's nice to use SSH so you don't have to put in your password each time. So what I'm going to do is head over to my file system and just go into this demo folder. So you're going to want to do two things. So first of all, you're going to need to make a folder for your Code Composer Studio workspace. So we'll just call it workspace. You can call it whatever, something more meaningful perhaps. And then I'm going to open this up in Bash. If you don't have Linux subsystem for Windows already running, you can't do this, but it's pretty easy to set up. So that's a separate thing. So I can hit Bash and it'll open up the terminal here. And so I can git clone that repository. And so now we can move into there. And so something we're going to need to do is initialize those git submodules. So it's just git submodule init, and then git submodule update. And then that actually does the cloning. And now you can move into the git submodules and make sure they're the version that you're expecting. So for example, I'm going to go into EX2 services The submodule has left me off at some random commit. I'm just going to check out master because that's I know what's on master. I don't know what's on this random commit. So now we're on master. That's what I want. Now we can go ahead and set up the workspace in Code Composer Studio. So I'm just going to go ahead and open up Code Composer Studio. It's going to ask me what workspace I want. I'm going to browse and just point it to that one I just created. So that's just an empty folder right now. So once you're in, it'll say, give you the option to import a project, which we're going to do. You just need to browse to that repository we just cloned. So it's right in here. ex2 OBC software, you just need to point it to the root directory. And then it will find this thing called can. It's called can as a legacy thing. Maybe we'll try to change that later. Just hit finish. So you can see, we can just go ahead and kill this getting started thing. Now we have the onboard computer software all ready to go with CSP all populated. So this is connected to the Git repository for CSP, and same with services. So it's nice to not have to worry about those so much. But one thing to note is that if you do make changes in the ex2 services file, you're going to have to make sure that you're in the ex2 services folder and push from there, because if you're up one directory from ex2 services and you add and commit here, your changes won't actually be applied to ex2 services. You have to make sure that you change directory because they're separate Git repositories. So just make sure that you don't leave any important changes uncommitted, which I've done many times. Okay, so you should be able to just go ahead and build this. So you can click this little hammer. You'll see a lot of errors or warnings, yellow warnings. Most of those are just inherent with the operating system. It says statement is unreachable, and that's because we have return statements in OS tasks that don't return. So that's usually okay. So yeah, that's mostly statement is unreachable. And then you can go ahead and hit this debug button, a little bug. And if your device is connected, then it should just upload. So once we hit run and pause it just to verify that it's in some FreeRTOS tasks, because sometimes if there's an error, it won't throw an error, it will just end up in some really weird obscure assembly file. If you pause the execution and see that it stops and you're in some random .asm file, something's probably wrong. But this looks good, it's just in the operating system. So that's just usually a good thing to make sure that it's actually running. Okay, so now our hardware is actually running the services and the CSP server. Another thing you can do just for sanity is put breakpoints in the code, and we'll show that once we have the ground station running.